Alright, so good to have you in Classore. I am Daniel Igbe, your very best chemistry tutor. Now in Classore, I have arranged the topics in systematic order from what is chemistry. What is chemistry, for instance? It has to do with the study of the uses, the properties and composition of matter. And then from there we get to learn what matter is, but we didn't stop there. We went on to look at the composition of matter, and that is actually the rudiment of chemistry. What are the three compositions of matter? We have atoms, molecules, and ions. You see, your understanding of these three makeup of matter will actually enhance your chemical journey. You get to know what an atom is, how atoms combine to form molecules, how the loss of an electron or the gain of an electron forms what we call an ion. And then from getting to know what an atom is, we move on to discuss elements. Alright, element, it is not the basic in chemistry, atom is. So from atom we get to know element. These elements have atoms. And then we had extensive class as to what an element is, and then I did a study. I gave the first 30 elements. I want you to be ahead of your peers. I would have given you the first 20, but I made it the first 30. Okay, challenge you to know many ahead. Just before you're done with SS3, you should be able to know at least the first 50 elements. And then we went on to describe how two elements can come together to form a compound. Alright, where we said a compound is two or more elements chemically combined. We also went on to describe mixtures. Mixtures can be made up of several elements that do not react. It could be compounds and elements that also do not react. So one distinct difference between a mixture and a compound is actually in the chemical change. So compounds are a result of chemical changes. Mixtures are a result of physical changes. So we also went on to describe what physical changes are, what chemical changes also are. And then from there we talk about electronic configuration. Your understanding of the proton content, the electron content, and the neutron content of the element actually enable you to do what we call electronic configuration. And then in electronic configuration, we get to know the placement of an element in the periodic table. For instance, the valence electron tells us the group of the element in the periodic table. The number of electron shells also tells us the period of the element in the periodic table. And the valence electron also tells us about what we call valency, the combining power of elements. I've seen students who are unable to write simple formula for simple compounds. For instance, you ask them, what is the formula for sodium oxide? They say sodium oxide NaO. That's actually wrong. Why? Because they just combine the two elements. What about just writing HO as the formula for water, since water contains hydrogen and oxygen? Why is it H2O and not HO? The principle is inside the combining power. You need to know what the valency of an element is of another element also, such that when you combine, there is an interchange of valency. And from there also we get to learn about oxidation number. And we took a step further. We looked at chemical combination, where we discussed bonding. You see, we talk about the electrovalent bond, talk about ionic bond. We get to know how compounds are formed and the bonds that are present in some of these compounds, from ionic to ordinary covalent to dative bond to metallic bond. And then we took a step further. We looked at periodicity. Not just the periodic table, we looked at periodic properties like atomic size, atomic radius, ionic size, ionic radius, ionization energy, electron affinity, electronegativity, electropositivity, boiling point and melting point. We look at their trends in the periodic table across the period and down the group. We also went on to look at gas laws, all the laws from Charles law to Boyle's law to general gas equation to ideal gas equation to Graham's law of diffusion to Gay-Lussac to Dalton's law to Avogadro's law. All of these things were thoroughly taught with questions solved. We went on into some advanced physical chemistry also. We talked about rate of reaction. We talked about redox electrochemistry. You see, I had to do redox before electrolysis, because your knowledge of redox will help you to know just how to go about your electrochemical reactions. And then we looked at Faraday's law, simple concept. I was able to simplify the whole calculation in Faraday for your comfort. And then we went on to talk about chemical equilibrium. We looked at the major. What is the major? The law of mass action in deriving what we call equilibrium constant formula. We also went on to discuss Le Chatelier's principle, which helps us to know what happens to the equilibrium position for any reaction that is in equilibrium. And then we'll also discuss non-metals. In the non-metals, I have to use some written notes so that I don't miss any point in teaching you that concept. Also in metals, I also have to hold the notes so I don't miss any vital point in ensuring that your distinction is intact in the forthcoming exam. And of course, the almighty topic, which is organic chemistry. I call it the simplest topic in chemistry. We're able to also take it in systematic order, from what an homologous series is, to what an alkyl is, to what a functional group is, to what general formula is, to naming compounds from carbon 1 to carbon 10. And then we look at the IUPAC nomenclature. We didn't stop there. We'll also look at some organic reaction. And of course, there we'll also have the nuclear chemistry, the most simple topic also in chemistry. So these whole topics have been arranged, well taught, question analyzed, quiz is set for you so you can enjoy everything in chemistry. I can assure you, chemistry is not as hard as they have told you. It is as simple as I have taught it. I look forward to seeing you in the classroom, and I look forward to seeing your result from the quizzes and the test. I look forward to hearing your questions, and I look forward to giving you beautiful answers. As we journey in this whole chemical adventure, it's going to be a beautiful trip, and I look forward to having a good working student-teacher relationship with you. Till then, keep succeeding. God bless you. Say to yourself, I am getting better. I will see you in the class.